Good day, everyone. We are working out number 3 of May 2021, paper 2, CSEC Mathematics. We have a triangle here. We are asked to find the size of angle PRQ. So it's located where the middle letter is, capital R. That's the angle we are asked to find, question mark. So this box in the corner here represents 90 degrees. Automatically, it is 90 degrees. All right, angle PQR. And we are told that it's 90 degrees, all right? So in order to work out the size of PRQ, we remember that a triangle has 180 degrees internally, okay? The sum of the interior angles of all triangles is 180 degrees. So we add 90 and 62, all right? And we get 152 degrees. After that, we subtract from 180. 180 take away 152 and we get 28 degrees. Okay, so R would be 28 degrees. All right, angle PRQ is equal to 28 degrees. The length of side RQ. Okay, so we know all the angles inside the triangle, and we want to find the length of RQ. And we could use angle RPQ or QPR, which is 62 degrees. Okay, and we remember our acronym, so CA. Right, so CA. TOA, right? And this helps us to remember the formulae for the sine, cosine, and tangent ratios. Okay, so if we are using angle P, then RQ will be opposite to angle P. Okay, and the longest side is called the hypotenuse, which is opposite the 90-degree angle. Okay, so if we are using angle P with 62 degrees, we will use sine. All right, so we'll write sine P is equal to opposite over hypotenuse as evidenced by our acronym sine. SOH means sine is equal to opposite side divided by hypotenuse. Okay, so that will be, we want to find the opposite RQ. It's called RQ. Hypotenuse is 11 centimeters and P is 62 degrees. So we have sine 62 is equal to RQ divided by 11. So we, with our calculators, we find sine 62 to 3 decimal places, 0.883. Always to 3 decimal places. And we want to solve this equation. We multiply both sides by 11. 0.883 times 11. All right, and we get RQ is equal to 9.7 centimeters to 1 decimal place. All right. All right, so it's approximately equal to 9.7 centimeters. Moving on to part B, the diagram shows 3 triangles XYZ on a square grid. Triangle X is mapped onto triangle Y by reflection. State the equation of the mirror line. So, all right, the distance of the object from the image, all right, must be divided by 2. Okay, so if point X, triangle X has a point here that is 2 units away from the x-axis, all right, and the image is also 2 units away from the x-axis. All right, same thing over here with this point. All right, so we have 3 points on this triangle, and it is 4 units away from its image, its respective image. So we have to divide 4 by 2, and we get 2. So therefore, 2 units down, we will meet the mirror line. And the mirror line is the x-axis, which can be written as y is equal to 0. All right, this is the mirror line, or x-axis. All right, let's just highlight that. The mirror line is the x-axis in red. All right. All right, so let us look up the equation of the mirror line is y equal to 0. Describe fully the transformation which maps triangle X onto triangle Z. Now, triangle X and triangle Z. Let's see what's going on here, right? All right, so let's try to connect one point with the origin because the orientation of the triangle has changed. Therefore, this is not a translation. All right. The size of the triangle has not changed. Therefore, this is not an enlargement. All right, so this could be a rotation because it's definitely not a reflection. All right, let us check and see. Let's use the origin. All right, we guess that it could be the origin. Let's try it out. That's one of the popular choices. All right, so let's look at this point. Let's draw a line connecting it. Let's draw another line connecting this point. All right, and let's just see if we could guess this angle. Okay, let's see if we can guess this angle is L-shaped. All right, if you have your protractor, what you can do is measure this angle. You'll find that this is 90 degrees. All right. If you take another line here and you connect it to its image, you will find that this angle, right, is also 90 degrees. And if you draw another line, so the diagram will get a little messy. But if you draw another line through the image, right, to its respective object, right, you will find that you have another 90 degree here. So it's a 90-degree movement in this direction, following this arrow. Okay, and this is a anti-clockwise direction because it's opposite to the motion of the hand of a clock. So it's called anti-clockwise. Okay, so this is a rotation. Firstly, it's called a rotation. Since the orientation of the triangle has changed, a rotation of 90 degrees in an anti-clockwise direction about the origin. So the origin is the center of the rotation. All right, so you could put 0, 0 here. All right, on the diagram on page 10, translate triangle Y using the vector -7, 1. Translate the triangle Y. So we are moving triangle Y. Translate means to move from one place to another, right? Now, -7, the number on top tells you whether you're going to the left or to the right. This is 7 units to the left. If it is negative on top, you're going to the left. Positive underneath means 1 unit upward. The number underneath tells you whether you're moving up or down. If it's positive, you move up. Okay, so let's move 7 units to the left and 1 unit up. So we will take each vertex of the triangle and we'll translate it. So let's use this vertex here. So we're moving 1, 2, 3, 4, 5, 6, 7, and 1 up. Okay. Also, we have 1, 2, 3, 4, 5, 6, 7, and 1 up. And for this point, this vertex, we have 1, 2, 3, 4, 5, 6, 7, and 1 up. And this gives us our image. Okay, so with our rulers, we draw very straight lines. Okay, and therefore this is what we have, capital V, as we were asked, all right? They said, translate triangle Y using the vector and label this image capital V. So we did it, we labeled it capital V. All right, let's look at this one now. On the diagram on page 10, enlarge triangle X about the center, C00, and scale factor 1/2. Label this image W. Right, so we are given a center of enlargement and a scale factor of 1/2, which means that this triangle X is going to get smaller. All right, that is just, so that's not working. All right, so this triangle needs to get smaller. Okay, so we want the triangle to get smaller. So what we're doing is we are starting from 0, 0. And what we are doing is we are moving out. All right, let's move out from the origin and find out the coordinates of each of these points of the triangle. Okay, so we have 1, 2, 3, 4, 5, 6 to the right and 1, 2 up. And we want to divide 6 by 2 because we are multiplying it by 1/2. So we'll move 3 across and 1 up. All right. So we divide 2 by 2, 2 into 2, 1. So we move 1 up, and we divide 6 by 2. So we get 3. So we'll move 3 across and 1 up because we are doing everything. We are doing everything half as much, let's say. Okay, so let's look at this vertex on top here. We went 1, 2, 3, 4 across and 1, 2, 3, 4 up. Let's divide by 2. So let's go 2 across now and let's go 2 up. So we have another point here. And for this one, we went 0 across and 2 up. So let's divide by 2. So 0 divided by 2 is 0. 2 divided by 2 is 1. So we're just going 1 up. And we will just draw our triangle. All right, following these 3 points. All right. Let's draw straight lines. All right, to connect this. All right, of course. Yes. Okay, so this is our triangle. All right, good. So this is what we would call capital W. Capital W is our image after enlargement by 1/2. Okay, so the size has been reduced by 1/2. Okay, thanks for watching this video. This is the end of number 3. Do have a good day.